The world we currently see has been built through the rapid advancement of technology. And with this advancement, the materials used to make and improve these technologies has evolved. From the use of stone to bronze to steel, the human understanding of these materials has propelled us much further than our ancestors could have comprehended. Scientists now believe that they have a new high-strength material that can further advance humanity. But as with all synthetic materials, there are environmental impacts to consider. High-strength synthetic materials are one of the most important materials used in the modern world, with access to these materials determining the pecking order of countries across the globe. The production and development of these materials comes with a high environmental impact, with high-strength metals alone being extremely carbon-intensive and contributing hazardous waste in large quantities. In 2018, the world produced close to 1.7 billion tons of steel, and from this production, 3.2 billion tons of CO2 were emitted into the atmosphere. With the production of metals on the rise, as developing countries enter their industrial age, carbon emissions are set to increase drastically. With this further development of the world, structural materials that are less carbon intensive to produce need to be investigated. One option is a new experimental material. And no, it's not vibranium. The material is wood. Well, densified wood, that is. You might be thinking, wait, what? Wood? How could that be comparable to materials like steel, aluminum, or other alloyed metals? Well, this isn't your everyday run-of-the-mill wood. This is a chemically engineered wood that has been compressed to improve its material properties. This is a two-step process that works on either hard or soft woods. The first step is to partially remove the lignin and hemicellulose. This is done by boiling the wood in an aqueous solution of sodium hydroxide and sodium sulfite. The second step is to compress the wood using a hot press to totally collapse the cell walls, reducing thickness by about 80%. This densifies the wood while keeping a very high proportion of cellulose nanofibers aligned. From this process, a low-cost, lightweight material is produced that has all the desired mechanical properties engineers are looking for. It has a mean tensile strength of around 420 megapascals, which is around 10 times higher than untreated wood. This value is much higher than that of most aluminum alloys currently available. It's even higher than most hot-rolled plain carbon steels. This allows the material to easily be substituted in most statically loaded applications. Equally important to tensile strength is material ductility and resistance to impact loading. For this, a Sharpie test was completed on the material. The test showed a mean impact toughness of 11.5 joules per squared centimeter. This value is around 10 times higher than that of untreated wood, and it falls into the higher range for metals and alloys. This material even showed impressive results in compressive strength tests, with 5.5 and 40 times higher along and perpendicular to the wood growth than that of natural wood. And, because who doesn't like to shoot things, the material resistance to ballistics was tested. This was done to test the feasibility of a lightweight, bulletproof material. To do this, the densified wood was placed in two variations, a single layer and a 5-layer sample with 3 mm thick layers. From the results, it was shown that a single layer sample was unable to stop a projectile, but was 7 times more resistant than natural wood. The 5-layer sample showed that a projectile will penetrate the sample, but it will be trapped in the middle layers and won't completely exit the sample. Well, this is nice, but aren't we ignoring the environmental impact that producing this material will have? If this is what you are currently thinking, it is a valid concern. Land use, harvesting and milling of trees, and the carbon emissions associated with these operations are all impacts of the forestry industry. These are detrimental to our environment and becoming rising concerns associated with climate change. As of 2007, the gross greenhouse emissions of the forestry industry across the world are around 890 million tons of CO2 per year. However, there is around 420 million of a net positive effect from the industry. This means net emissions are around 470 million tons per year, and it is decreasing every year with efforts to find less carbon-intensive ways of doing things. While the production of this material will have an impact on the environment, its effect on the environment needs to be compared to that of other materials used for the same applications, namely steel and aluminum. Because densified wood is not in mainstream production yet, plywood was selected for the comparison, as the processes to make it are similar to that of densified wood. Carbon emissions due to the production of plywood produced in Canada are negative 1.5 tons of CO2 per ton of plywood. This value is negative due to the net positive processes that happen in the industry in which CO2 emissions are sequestered during production. When comparing this to the values of steel and aluminum, the difference is staggering. For steel, the average emissions is 1.8 tons of CO2 per ton of steel, but for aluminum, the average emissions is 16.5 tons of CO2 per ton of aluminum. While the material properties of densified wood are good, and the decrease in carbon emissions is evident, there is still one major environmental concern. If densified wood was to completely replace the world's demand of just aluminum, the amount of deforestation that would happen would be devastating. While it seems that this material can't completely replace our demand for aluminum, or metals in general, it should be considered as a viable option to reduce our greenhouse gas emissions and help stem the tide of global warming.